Okay. Paul's here. Hi, Paul. Okay, so for this week, again, we're continuing to move on, we were kind of going to look at lesson 4. Again, everything has to deal with circles. Then there was a quiz, and then we had a couple more lessons on circles as well. So we'll finish up circles this week, and then next week we'll take the test and then start our next unit, unit 13. So again, just kind of looking ahead, we're going to finish up our lessons on circles this week, review, take the test next week, and then start our new unit. So I was gonna kind of just run through real quick a couple of the big ideas from this week. And there are sort of some like equations. And so again, I want to make sure that you've got a chance to write down those equations before we get into our practice time, because if you don't have the equation, sometimes that makes it very, very difficult to work through the problems. Okie dokie. So have something to write with, a pencil, a piece of paper, and we are gonna just do a very, very quick overview recap of this week. So the first lesson, lesson 4, talked about an inscribed angle. So that's different because we've seen central angles before. And again, central angles just go from the outside of my circle to the point in the center. Inscribed angles go all the way to a point on my circle and then go and touch another point. So it's two secant lines that connect at the same point. So this, again, the example here is is angle ADB. And really the big idea with inscribed angles is that whatever my angle is, it's going to be half as big as the arc measure. So you can see that arc AB is 80, which means that this angle over here is going to be 40. Now it works both ways. If the or if I have the angle, then I can multiply it by 2 to get the arc. So again, depending on what you have is going to determine sort of what we need to do. So the inscribed angle is half of the arc measure. That's really kind of a big idea. Again, this kind of idea, opposite angles are supplementary. We've used that word supplementary all year long, which again means adds up to 180. So opposite is like a cross, and supplementary means adds up to 180. So we can use that to solve problems as well. Lesson 5, looking at angle relationships. So this example, if a tangent and a chord, so again, tangent touches my circle one time, a chord is like what connects these two. A chord doesn't go through the center. Then the measure of each angle formed is 1/2 the measure of its intercepted arc. So again, angle 1, if I look at angle 1, that's going to be half as large as AB. And that's highlighted in green. If I look at angle 2, that's like the dotted line over here. Angle 2 is going to be half as large as the major arc BCA. So again, just maybe jot these down, write this down, so as we get into our practice, you've got something to reference. And then when you have angles inside the circle, when you have two chords that connect, and again, they're not crossing at the center, well, you can kind of use that, a kind of a similar idea where, hey, we're going to take half of my arc DC, but I'm also going to add this other arc AB. So I'm going to take whatever my arc is for DC, and I'm going to take whatever my arc is for AB, and then I'm going to add them up and then divide by 2. And that's going to give me the measure of angle 1. And it's very, very similar for when we have an angle outside the circle, except there's one difference. If you look at this equation, we are adding the two. Down here at this equation, we are subtracting. So kind of the difference between, again, are my chords meeting inside the circle or are they meeting outside the circle? That's going to affect if I add or subtract in my formula. Let's see here, can I erase this? Okay, in this problem, let's see. I'll plug it right back in. We are looking at segments of chords. So again, maybe looking at not the angles this time, but the actual segments. Oh, I see it. Okay. And so what I can choose is I can say that these two segments are going to be equal. So I could take the segment EA and the segment EB, and I can multiply them together. And that's going to equal the segment ED, and it's going to equal the segment EC. So again, using what I know, I can find out what I don't know by following this kind of formula. Once you set it up, it just turns into a lot of algebra problems. It's kind of a similar idea. Again, just like we talked about last time, the two formulas are very similar. Kind of works the same here, where again, we're going to do basically that same idea, except this time our segments are going to be partly outside the segment. And then notice that it's EB is the whole thing. So it's not AB, okay? It's not AB because that wouldn't be what we are trying to calculate. So it's my whole segment, which again sometimes requires you to maybe add, say like this, that whole segment would be called x plus 5 on the bottom, and 9 plus 6 would give me 15. And if I only have part of it, so again, I'm missing, this is a tangent, I'm missing part of it, I have a slightly different formula again, where I can say EA squared, so again, EA multiplied by EA equals EC times ED. So slightly different, where up here, we were multiplying by the two segments. This time we only have one, but we can go ahead and square it. And this last equation, make sure you've got written down. It is how we write the standard equation of a circle. So again, if our center is 0, 0, with a radius of 1, we would say x squared plus y squared equals 1. Again, if we move left or right, we call it h. If we move up or down, we call it k. And r stands for the radius. Now, notice that the equation is subtraction signs, okay? So that means if you have a -2, it would be x subtract -2, x minus -2. That's going to cancel and turn into a positive, a plus. So your answer would be x plus 2. And then it's really manipulating that equation to solve, again, what we don't know. All right. Any questions real quick? Otherwise, we're going to jump into our practice. I'm going to put the link in the chat. Thumbs down to no questions, not thumbs down to the practice, right? Kidding. Okay. All right, so go ahead, click that link in the chat, please, and then go ahead and get started. We'll see how many problems we get through. We probably won't finish them all. That's totally okay. I'm going to share my screen and just scroll through some of them. So if you're watching the recording, you can pause it, try it on your own. Hard to see that one. Seven people. Let's say about 5 more minutes. Let's do 5 more minutes of this. Okay, let's go about 1 more minute. About 1 more minute working on this, and we'll do a problem or two together. Okay, let's go ahead and wrap that up. Because I want to touch base on, let's do two problems. Where is the end button? There it is. I had zoomed in. Okay. Let's look at 18. Okay, which equation matches the circle on the graph? If I look at this circle, okay, it looks like it has a center at x is 2, y is 1, 2, -3. So x is 2, y is -3, and then my radius is 1, 2, 3. So I need to find an equation that has x minus 2, y minus -3. So x minus 2, y plus 3, and then r squared is 3, which gives me 9. So x minus 2, y plus 3 equals 9. And the other one is number 20. Kind of the exact same problem. It's the same problem twice, it looks like. So I guess that would make sense as to why we got it wrong twice, or it was the most common one. Okay, let's take a look at your Class Connect assignment. Again, this is to show me that you were following along, that you were paying attention. If you're watching the recording, this is how you show that you understood what we were talking about. It's going to be right here in this folder. I'm going to open it up. Okay. How do we go about solving these problems? We need to multiply my two segments together. So I'm going to actually switch over to my notebook. Okay. So let's say we have this circle. Look at that. And we had something like this, and we had something like this, x minus 9, x minus 13, 32, 21. So again, I'm going to multiply this section by this section, and I'm going to multiply this section by this section and set them equal to 32 times 21 equals x minus 13, x minus 9. Some of these are going to be really easy to simplify. 32 times 21, 672. This I have to FOIL. I get minus 9x minus 13x. 13 times 9 is 117. So we're going to simplify this to minus 22x plus 117. So we got to make this equal to 0 first. Okay. This one's turning into a long one. All right, so now when we think about our factor x, I've got negative 37 multiplied by positive 15. And this was the point I wanted to make, was that 0 equals x minus 37, x plus 15. The reason that I can't have this be a possible answer, okay, no good, because x equals negative 15, that would give me a length. If I go back to the original problem, that would give me a length of negative numbers. And we know that we can't have a negative number for 0 or for a length. So what's my answer? X equals 37. That's for the first one. The second one looks like this. Okay, we've got, let me share it so you can see it. So what I'm going to do, I'm going to do that same idea. I'm going to do 9 times 32 equals x. And this is going to be multiplied by x plus x. So the whole thing is x plus x. And then my little segment on the outside of the circle is also an x. So it's kind of confusing. And I get that. So when we go through and look like this, 288 equals, you could say that this is x plus x is 2x. So this is 2x squared, divide by 2, 144. And then the square root of 144. Again, it's positive and negative 12. Negative 12 doesn't make sense. Negative 12 doesn't make sense. Therefore, my answer has to be positive 12. Last problem. I don't like when it zooms in like that. Okay. The diameter of a circle has a length of 12. The center is at x negative 5, 2. Give the equation. If the diameter is 12, that means my radius is 6. 6 squared is 36. So I know it's one of these two answers. X minus negative 5 is x plus 5. Y minus 2. So my answer is going to be right here. Okay, that's circles in a nutshell. Again, there's lots of little rules. Once you kind of get the hang of circles, we do a lot of the same ideas over and over and over again.